Greetings. Welcome to my presentation on backup and restore options for SQL Server in Azure. I want to thank the organizers of the Data Platform Virtual Summit for giving me the opportunity to present. Quickly, a couple of things about me. My name is Frank Gill. I have been working in IT for 22 years now. The last 14 years I have been working with SQL Server. I started out as a traditional database admin, and over the past 5 years I have worked as a consultant, and during that time I've become much more involved with Azure and SQL Server. My primary interest outside of my job with SQL Server is internals, so if you ever have any questions about dumping a page or the transaction log, I'm always happy to take questions. And if you have questions about anything in this presentation, you can contact me at one of these three sites: Twitter, my Twitter handle, my email address, and then my blog. And I joke that I like to talk about this stuff and my wife doesn't, so any and all questions are welcome. So to get in what we're going to cover today, I'm going to give a brief overview of the SQL Server options that are available in Azure. And then for both of those options, I will talk about the backup and restore methods that are available. And you might ask why I'm covering this information. And it is because there are too many choices. There are options for how you run SQL Server in Azure, and for each of those options you've got multiple methods for backing up and restoring your databases. And over the past 2 years or so working with clients, I've worked with these different methods, and I have found some things that were not obvious to me at the start, and then getting deeper into these methods and reading documentation in greater detail, I've learned some things that I think can be helpful if you are looking to use the backup and restore methods and help you choose the one that makes the most sense for you. So with that, we're going to get into SQL Server options in Azure. There are two high-level categories for the options in Azure. There's infrastructure as a service, and this is effectively SQL Server running on an Azure VM. So if you are running infrastructure as a service with SQL Server, you are effectively using Azure as your hosting provider. You have a virtual machine. That virtual machine is running SQL Server. And you've got two different ways to provision these. You can stand up a VM, Windows or Linux, and then you can install SQL Server on that VM yourself. And that is no different than installing it on a VM, running on your laptop, running in a data center, running at an on-prem hosting provider. Your other option is to create a VM from what's called a marketplace image. And this is a Windows or Linux VM, and you select the version and edition of SQL Server that you want to install. So the marketplace images exist for SQL Server 2008 R2 through SQL Server 2019, and you have access to all of the editions that are available for those versions. So for example, for 2019, you have Enterprise, Standard, Web, and you can actually install Developer. So you will not be, with Developer, you're not going to be charged for the SQL Server license. You will still be charged for the Windows license associated with the VM. Another thing that's very important to point out with infrastructure as a service is because this is a virtual machine that is running in Azure, you as the client are responsible for patching the OS and the SQL Server instance. Azure provides managed services, and there are different levels of management. So with infrastructure as a service, you're not getting that OS and SQL Server maintenance. From there, we'll talk about platform as a service. So platform as a service is a fully managed service. So with this, you have patching of the OS and SQL Server handled by Azure, and backups are fully managed. You have two options within Platform as a Service for SQL Server. There's what's called Azure SQL Single Database and Azure SQL Managed Instance. The single database is what it says. It is a single database. It runs on top of an Azure resource called an Azure SQL Server, and you can have multiple Azure SQL databases running on the same Azure SQL Server. But unlike a traditional install of SQL Server where you have an instance and you can run multiple databases there, you cannot use 3-part or 4-part names when referencing tables. So you can't have cross-database communication and you can't have cross-instance communication. For that reason, in a lot of cases, Azure SQL Single Database is not a good candidate for moving existing SQL Server environments into Azure, because in a lot of cases you're going to end up re-engineering your solution to deal with the restrictions of Azure SQL, the single database. The other thing that is very different than a normal instance of SQL Server is the single database offering does not have a SQL Server agent service. So if you have an existing environment and you are running jobs using SQL Server agent, you will not be able to move those jobs into Azure running against a single database. The second PaaS offering you've got is called Managed Instance, and this is a managed instance of SQL Server. So it is an instance as you are used to running SQL Server. You have the ability to do those cross-database queries. You cannot join between managed instances, but you can use those 3-part names for cross-database queries. And this does have a SQL Server agent. So you can move those jobs up to Azure. The managed instance is an option provided by Microsoft to ease that transition, ease that migration into Azure. You can take an existing environment and with some very few exceptions, you can move those directly into managed instance. And I will have a link in the resources section that will specify the things that aren't available in managed instance. And they are both at the administrative side and then at the T-SQL side. But as I said, it's approximately 99.9% of the feature set of SQL Server is available in Azure Managed Instance. So from there, we're going to talk about the backup and restore options for PaaS. So the question, and we're going to get into that. So the options for PaaS are actually pretty limited because the backups are fully managed. When you create a single database or a managed instance, Azure automatically begins managing the backups for those databases. And that includes the backup schedule, and it also includes the backup location. These things are configured within Azure. You cannot change them. You can see what they are to an extent, but you have no ability to change either schedule or location. You can set the backup retention, and there are limits there. Talk a little bit more about that in a second. And you cannot directly access the backup files. So there's no drive location you can go to and see your backup files. And finally, and this is an important point that I've run into, is if you are using any kind of third-party tools to do your backups currently, those tools cannot access backup or cannot do anything with backups for the PaaS offerings. Microsoft has not exposed the APIs for backups for PaaS databases, and so there's no way for second or third parties to run those backups and do restores from the existing backup files. And I've had third-party vendors tell me that they can, and it's been a back and forth until they finally admit that they can't. So just keep that in mind when you're looking to make this move. The backup schedule for PAS runs as follows. So when you create a database, a single database, or you restore a database to a managed instance, the Azure will immediately kick off a full backup of that database. Once that full backup runs, it will begin running log backups. And the backup schedule is you will run a full weekly, you'll run a differential daily, and then you'll run log backups every 5 to 15 minutes, and that duration is based on your transactional volume. So if you have an increase in transactional volume, let's say your application gets busy between 4 p.m. and 6 p.m., that log backup frequency will increase to 5 minutes. As that transactional volume is reduced, the log backups will run less frequently. And the idea here for both single database and managed instance is to give you point-in-time recoverability. And you set the retention, talk about location. So as I said, you don't have control over the location, but the backup files are taken locally, and then they are GeoRedundant. And so what happens is you write the backup locally to a local file, and then that file is copied to 2 other drives or 2 other locations within Azure. So you have 3 copies local, and then each Azure data center has a paired data center, and another copy of your backup file will be written to that paired data center. And so this gives you both high availability with your 3 local copies, and then disaster recovery with the file written to that paired data center. So you will always have access to a backup file, even if your primary data center where your databases are running, connection is lost to that completely. So that is the location. And then the retention, as I said, the whole point behind this automated backup schedule is to give you point-in-time recovery. And when you stand a database or a managed instance up, that point-in-time recovery range defaults to 7 days. It's outside of the scope of this presentation, but within PAS you have different tiers available to you. And just know that if you are running at the basic tier or at the hyperscale tier, that point-in-time recovery limit is 7 days. The reason for that on the basic side is cost. They are limiting their sort of exposure to cost with basic, and then hyperscale, the architecture of the hyperscale tier works differently than the other tiers, and you have recoverability beyond that 7-day limit through other means. For the tiers that are not basic or hyperscale, you can increase that point-in-time recovery to 35 days, and for all of the tiers you can really reduce it below 7 days down to 1 day. Okay, so that's point-in-time recovery. And then on top of point-in-time recovery, you have the ability to do long-term retention. And you can retain weekly backups, monthly backups, and yearly backups for a longer period of time. And each of these you can retain for up to 10 years. And this option is available for clients that have auditing requirements or legal requirements that make it necessary for them to hold on to backups for longer than the 35-day point-in-time recovery period. So, one other thing to mention is that backups are fully managed for both single database and managed instance, and you have no ability to take an ad hoc backup for the single database option. You can pull what's called a backpack file. You can export the database, and a backpack file is effectively a script file that contains all of the objects in the database and then all of the data in the database. So it is not a backup per se, or it's not a file that you want to generate on a schedule. It's there to be able to pull the data out of Azure and restore it somewhere else. So that is true for single database, but for managed instance, you do have the ability to take a copy-only full backup. That copy-only full backup must be written to Azure Blob Storage, and then you can take it from Azure Blob Storage and you can restore it to another instance of SQL Server in Azure, or you can pull it down to local storage and restore it on a test machine or on your laptop. So you do have that option with managed instance to take a copy-only full backup. So with that, we're going to jump over and take a look at a demo. So I am looking at the Azure portal here, and this is my Azure SQL Server. And you can see that here. And under the Azure SQL Server, down at the bottom, I have one database running on this Azure SQL Server, and that is FG SQL DB. And then on the left-hand pane, under Data Management, I have backups here. So if I click on backups, it will take me to the backup screen, and it defaults to the available backups tab. And you can see that I have my one database, FBG SQL DB1. It tells me the earliest point in time restore point, and that is the 23rd of August at 8:09 p.m. UTC. All the times are going to be in UTC, and that is the earliest point I can go back to, and that is in fact my creation date. So I am recording this on August 30th, and as soon as I move past the 7-day window, because I'm using the 7-day point in time recovery window here, that last restore point will move forward in time. I don't have any long-term retention backups available. I do have a manage link here, and I'm going to show you what that looks like on the retention policies tab in a second. And then if I do want to do a restore, I click this button here. So let me go to retention policies and just show you what that looks like, and then we'll come back in and take a look at a restore. So if I click the retention policies tab, once again, I have information about that one database. You can see my point in time restore is 7 days. I can set the differential backup frequency here. So right now I have it set to 12 hours. I can also set it to 24 hours. And then for long-term retention, I just have a yearly backup being retained for 10 years. So if I click the checkbox next to my database name and select Configure Policies, it will take me into this pane, and here I can set my point in time restore threshold. I can flip the differential backup frequency, and notice that this is a preview feature, but I do have that drop down for 12 or 24 hours. And then here is where I set my long-term retention. So I've got those yearly long-term retention backups. I'm keeping an annual backup for 10 years, and then I have the ability to select which week I want to keep. So in this case, I'm keeping week 1. This drop down will show me weeks 1 through 52. So if you need to keep the last week, backup for the last week of the year, so you have all of the previous year in a single backup, or if you want to pull week 1 and then you've got basically week 1 of the past year through week 1 of this year. It's up to you. You have the option to select whichever of those weeks you want. And then I can just edit these. So let's say I want to keep a weekly backup for 12 weeks, keep a monthly backup for 12 months. I can make these changes, click apply, and it will give me an "Are you sure?" because the more backups you retain, the more you're going to pay, because you're paying for the storage to store these backups. So it's just something to keep in mind. And I'll have a link in the resources section to a cost calculator that will allow you to see for each region and each tier how much you will pay to use both point-in-time restore and long-term retention. So I'll click yes here. This will clock for a second, and give it a second to run, and there you go. So it should be complete now. It's still showing as deploying, but you can see that weekly long-term retention and monthly long-term retention are now both populated. So as those points get hit, it's going to write those backups out to a long-term retention location, and they're succeeded, so everything is set. So that is point-in-time restore and long-term retention. And actually I didn't show, I'll just show real quickly. This is the point-in-time restore, and then I can move that up and down using the slider bar, and I can also manually edit that number in the little text box here. So got both those options. Going to cancel out of that because I'm not making any changes. So if we flip back to available backups, once again, earliest point in time, if I click the restore button, it will flip to this pane, gives me information about my subscription and my resource group, my database, and then I have the ability to select point in time or long-term backup retention. I'm going to use point in time in this case, but if you did need to pull something back from long-term, you can do it here. And then it'll give me the earliest restore point. And this is grayed out because you can't change it. That is a fixed value based on your point in time restore window. But I can specify a restore point. And it will populate the restore point with the most recent restore point available to you. And you can choose any restore point between that value that is pre-populated and the earliest restore point. So if somebody did something at 10 a.m. this morning and you need to recover from it, someone ran a delete without a where predicate by mistake or dropped a table or whatever the case may be, anything that you need to restore for, you can restore to any point in time between earliest restore point and the most recent. And then one other thing to point out is that there is no with replace option with restoring a PAS database. So with a normal database running on an instance of SQL Server, when you do a restore, if I have database FBG SQL DB1, I can restore to that database name, and all I have to do is put replace in the with clause on my restore, and that tells SQL Server overwrite the existing database. You can't do that here. So what you need to do is restore to a different name and then drop or rename the existing database and then rename this database. So in this case, it's giving me a name, and I can edit this if I want to, of FBG SQL DB1 underscore with a date time value. It's going to restore to that name, and then I can verify that the data looks good in that database, drop the existing FBG SQL DB01 or DB1, and then rename this to the desired name. Something else to point out here is compute and storage. So because the database that is being backed up is standard S0, which is the tier that it's running on, that is what it's going to default to restore to. I have this running at standard S0 because it costs about $15 a month, and I'm running on my employer subscription, and the less they get charged, the happier they are. But I can click this configure database link, and it gives me the ability to select a different tier. I can select a different DTU, DTU-based purchasing model or a vCore. And the difference there, the DTU model, effectively a DTU is a roll-up of memory, CPU, and I/O. The vCore model, you're actually purchasing virtual cores, so it's more similar to what you're used to if you're doing an install on a VM. You know how many processors you have, and you can bump those numbers up and down. But just know that you can modify that from the tier of the backed up database. A reason that you would do that is if you have, let's say, a production database that's running on a really beefy, if you're using a large number of vCores and you want to restore that database to a test system and you don't want to use as many vCores because you want to reduce costs, you can do that here. So I'm going to close out of this. And then one other thing to point out is I mentioned that you've got the GeoRedundant backup storage where you've got the 3 copies local and then 1 copy that is written to a database pair. You can modify that here. So you can have locally redundant and zone redundant, and those two are both in preview, but that is another way that you can reduce cost because that GeoRedundant is going to increase your cost by some amount. And if you drop that to locally redundant, you're only going to have it local, but with a test system, because you're restoring from your prod system anyway, you may not need that. So just something to keep in mind there. So that is kind of the restore administration that's available to you with a PaaS offering. And while these examples are all using the single database option, the options are the same for managed instance. The reason I'm not showing you managed instance comes down to cost, because managed instances are more expensive than the single database. And once again, running on my employer subscription, less cost is better. But just know that this will look the same for managed instance. So let's jump back to my slides. So backup and restore options for IaaS, and there are quite a few more here because it is not managed by Azure. The first one I'll talk about are native backups. So managed instance, I'm sorry, not managed instance, SQL Server running on an Azure VM, you have the ability to run backups like you would anywhere else. You can take backups using your SQL Server agent jobs, just like you are able to in any other environment, and you can roll your own schedule. You can create your own full backup job, you can create your own full backup schedule, same for differential and log backups. Or you can use Olas Solution's maintenance solution. If you are not familiar with Olas Solution, it is a script that is available for free download from olahalengren.com, and you run that script and it creates a table, a number of stored procedures, and I believe it's 8 agent jobs. And among those agent jobs are a full backup job for system databases, and then full backup job, differential backup job, and log backup job for user databases. They get created. There's no schedule set on creation, so you can manually schedule these or apply an existing schedule to them, and you are responsible for that scheduling. You do have the ability to control the backup location here, as you have the ability to control backup frequency. And I will show you when we take a look at a VM what that looks like in terms of the drives that you have available to you, and you can add additional drives to an Azure VM. So, second option is what's called automated backups, and this is kind of a hybrid of the managed backups available for PaaS and the IaaS offering on the virtual machine. So on the virtual machine itself, you can enable automated backups, And then you have the ability to create either a manual schedule. So you say, okay, I want to run a full backup at 1 a.m. on Sunday. I want to run diffs at 1 a.m. Monday through Saturday. I want to run a log backup every 2 hours. You can do that, or you can turn an automated schedule on. And in this case, Azure will control that schedule. And one of the things that this gives you is that log backup being run on based on transactional volume. So just like the PAS offering, if you start to write more data to your database and your transactional volume increases, that backup frequency will automatically increase and run more frequently. One thing to point out with automated backups is with running them your own, rolling your own, running native backups, you can write those to a drive on the server, or you can write them to Azure Blob Storage. Automated backups requires an Azure storage account. So you have to have an Azure storage account. You have to write those files to Azure. So let me show you the automated backup demo. So this is a virtual machine that is running SQL Server 2019, and under Operations here in the left-hand pane, I have a backup option. If I click that, it will take me, oh, you know what, did this before, hold on a second. I don't want the VM. What I want is the SQL virtual machine. And okay, so when you create an Azure VM from a marketplace image, you get two resources. You get the virtual machine, which is what I was just looking at, and you also get what's called a SQL virtual machine. And this is where I'm going to set my backups. So if I click the backups link here under settings on the left-hand side, that will take me here. And as you can see, I've got my automated backup. It gives me a description of how that works, and I can enable automated backups. Once I do that, it will give me some options. I can set a retention period anywhere between 1 and 30 days. This is where I select my storage account, and then I can encrypt these backups. I can tell it to back up system databases. So with this disabled, it's only going to back up the user databases on your system. If you want to back up master, model, and MSDB, flip this switch. And then finally, here is your backup schedule. So it defaults to automated, where it will take the backups. If I click manual, it then gives me options to modify that manual schedule. So that is automated backups. Just keep in mind, the options you've got and the fact that you need an Azure storage account to be able to run the automated backups. So while we're looking at that, let me flip over to a VM and I'll show you what Olas jobs look like. So this is the virtual machine. It is running an instance of SQL Server 2019, and I have one user database out here. It's a copy of the Wide World Importers database. If I expand out jobs, these are the jobs that I mentioned. You've got your database backup jobs. One thing I didn't mention about Olas Maintenance Solution is that the maintenance solution contains backups, integrity checking, and index optimization. And so if you look from that top, database backup system database is full, and then you've got the 3 user databases jobs below that. Then I've got my 2 integrity checking jobs for system and user databases, and then finally an index optimized job for user databases. Those get created when you run the maintenance solution as a whole. But at Ola's site, there is a link where you can just pull down the backup functionality. So if you don't care about integrity checking, or you're doing integrity checking through a different method, same for index optimization, you can just specify backups and it will create these resources. But out of the box, it creates these 7 jobs. We're interested in the backup jobs. So in this case, I have the full set to run every Tuesday at 4:30 a.m. My diffs should be set to run every other weekday at 4:30 a.m. Yes, so you can see Monday, Wednesday, Thursday, Friday, Saturday, Sunday at 4:30 a.m. And then my log backups are running, get the dialog to open. Log backups are running every 2 hours. And I mentioned that you can write these either local to your server, or you can write them to Azure Blob Storage. In this case, if we take a look at the steps, I am specifying a directory equal to null, and that will take the default backup path that the instance knows about. Because of the way the VM installs, it sets the backup path, and it's true of any SQL Server installation. The default backup path will be a path within the SQL Server installation path. So because I'm lazy and I did not change it, that will be under the C drive, program files, MS SQL Server. Because this is a default instance, it's MSSQL 15.MSSQL Server, then MSSQL, and then finally backup. One of the things I like about the Olas Solution is that if you don't do anything to change the backup destination, it will use a standard path to write your backups. And that path will be the default backup location, which in this case is this MS SQL folder, and then under that the backup folder. And then for each database on that instance that's being backed up, you will get a database level folder. And then under the database level folder, you will get a folder per backup type. So if we take a look at the full, you can see that I ran a full backup at 4:11 a.m. server time on the 24th. That's UTC time, so that would be about 8 p.m. my time. And then if we go back and take a look at diffs, I have 3 days worth of diffs. So I had a diff run on the 25th, 26th, and 27th. And the differential is there to reduce the amount of data that has to restore. So if I go to do a point-in-time restore, I would restore the full. I would restore the diff, in this case from the 27th, the most recent diff. And then if we take a step back and look at log backups, you can see I've got a bunch of them. And if we come down to the bottom, the last one of these ran at 4 a.m. on the 27th. The reason that I'm only seeing a backup from the 27th is that I was working on the VM on the 27th and I shut it down to save money. So the log backup is not fired since then, but had the backup been continually running, we would see log backups up until basically this point in time, or the most recent 2-hour window. That's something else to think about if you're going to roll your own backups on a server that you're potentially going to be shutting down to save money. You may want to pull a backup before doing that shutdown. But just to show you that you can write backups for an IaaS database locally. Okay, so that is Olas Solution, and just to demonstrate your ability to write ad hoc backups, you can change that path, either the default path, or you can actually specify a different location in Ola's job. So those are the options you've got for writing ad hoc backups or native backups within an Azure VM. And just speaking of ad hoc backups, you have the ability to run as many backups as you want. You can run copy-only backups. You can run non-copy-only backups against the Azure VM databases. So that's that. And then the last option that I want to talk about for Azure VMs, SQL Server running on Azure VMs, is what's called the Azure Recovery Services Vault. And you can think of the Azure Services Vault as Azure Recovery Services Vault as sort of a one-stop shop for all of your backups. You can back up VMs, and you can also back up SQL Server databases. So if you want to take, if you have a policy where you need to back up your virtual machines every day or every week, you can set that within Recovery Services Vault. And then for the VMs that are being backed up that are running SQL Server, you can then set it up to run database backups. So this would give you coverage of your entire virtual machine infrastructure, both at the VM level and SQL Server. So there are some things to know here. You can set the Recovery Services Vault backups to be either locally redundant or GeoRedundant, like we talked about before. Locally redundant means that they're only written locally. If you can't get to your primary site, you're not going to be able to get to your backup files. So if there's a problem on the Azure side that renders that site, so your location, say, is East US, you can't get to East US, you're not going to be able to get a hold of your backups. You can have them written to a data center pair, so you would be able to access them from that paired data center under GeoRedundant setting. GeoRedundant does cost more, and you set backups in the Recovery Services Vault using what's called a backup policy. And this is where you'll set your schedule, and then you apply that policy to the resources, your VMs and your databases. You need to keep in mind that when you create that policy, you set whether it is locally or geo-redundant. Once you have done that, you can't change it for that policy. So it's something to keep in mind when you're creating a policy. Make sure you set that to the value that you want, because if you set it and then you want to change it, you have to create another policy and then add all of the resources that you're backing up there. We ran into this with a client who had a policy for their test system and a policy for their prod system. They wanted GeoRedundant for prod, but not for test. And it used to be that GeoRedundancy was your only option. So they didn't make a mistake. They just couldn't choose locally redundant. So then it became available, and they wanted to make the switch. And so they had to create another policy, disable the existing policy, and get everything added into the new locally redundant policy. Another thing to point out is that when you are backing up a SQL Server VM, so the actual VM backup, there is an option to back up OS disk only. And you want to set that because you are backing up your databases. And if you are backing up your data in log files, one, those backups can cause contention with SQL Server because it's pulling a backup of the drive, and that could prevent or make it harder for SQL Server to access the files on that drive. And then second, because you're taking the SQL Server backups, you don't have the need to back up those data and log drives. The portal, when you look in the portal under Recovery Services Vault at your databases and your VMs, you will see a backup health for each backup item. So if I have 10 databases that I'm backing up with Recovery Services Vault, when I look in the portal, I will see all 10 databases listed, and it will give me a health for each one. And something that I discovered when working with this tool is that I've got that schedule running, and let's say I'm running full backups every night, and then I'm running log backups every 2 hours. It is Monday today. If my full failed on Sunday, but my log backups have continued to run, I have a valid backup chain, and technically my database is healthy from a backup perspective because I will be able to restore that full. Let's say my full ran successfully Saturday, I'll be able to restore that full, and then I can restore all of the log backups from Saturday, Sunday into Monday and get to a point in time. But that is labor intensive to a point that I may not want to deal with. So you will get alerts from Recovery Services Vault if a backup fails. So you want to make sure that you have a process in place to check that backups ran successfully, and if they didn't run successfully, figure out why. Because Recovery Services Vault is basically that one-stop shop. It's supposed to give you a single pane of glass into your backup infrastructure, and when I look at a page that tells me that a backup is healthy, it makes me think that things have run successfully. So just know that it's possible to have backup failures and still have that backup health show as healthy. Another thing to point out here is that you can enable and disable RSV backups, and they are enabled and disabled at the database level. And this can be a little cumbersome if you have a large number of databases that are being backed up. One of the things that I've run into is you can back up availability group databases using the Recovery Services Vault. And so if you need to restore an availability group database, you want to stop backups from running against it. So you can go in, and if I've got 8 databases, I have to go through the portal and disable backups for each one. There are PowerShell and Azure CLI commands for Recovery Services Vault, but what I've found is that you can do some stuff with PowerShell, you can do some stuff with CLI, but you can't do everything with either scripting language. And I have not had the time to figure out if it's possible to write a scripted solution to remove everything and then put it back using a script. And as I say here, the disabling and enabling needs to be done manually through the portal as far as I have found to this point. I'm going to keep looking at it, and if I get an update, I will put it out on Twitter, so keep an eye on my Twitter feed. One other thing to know, or some other things to know regarding availability groups, is that with availability groups, one of the features is that you can offload your backups to a secondary replica. So with an availability group, you've got a primary replica that is running your databases, and then the log blocks associated with those databases are being replicated over to a secondary or secondaries. You can set a backup schedule on a secondary, and you can take copy-only full backups. Now this is running on a normal instance of SQL Server. You'd be able to do this using Olas jobs, but with Recovery Services Vault, there is no way to tell it to run a copy-only full. So regardless of the options you have set for your availability group, you can set the availability group backup preference to be secondary only, but that will be overridden by the fact that you can't run a copy-only backup. So those full backups will always get pulled from your primary node. So this is just something to keep in mind. The example that kind of made this an issue was we had a client, they had multiple availability group databases that we were using Recovery Services Vault to back up, and they had different kind of peak times. So the majority of them, we were running the full backups at 1 a.m. and it was fine. There was one that was being used for warehousing / reporting, and a lot of jobs, really resource intensive jobs, were running in that 1 a.m. window. So for that instance, we needed to create a second backup policy to run the fulls. I believe it was at 9 a.m. because that was an off-peak time for that instance. So just keep that in mind if you are backing up availability group databases, that those full backups are always going to run against your primary. And then to make it a little more complicated is the log backups will run according to that backup preference. So in the case of the AG where I have the backup preference set to secondary only, my fulls are going to run against my primary, but all of my logs will run against the secondary, which should be valid because if the availability group is healthy, all of that transactional activity is going to move from primary to secondary. But once again, just know that this is the case, and you want to make sure you know what's going on before you use this for an AG database. I believe this is the last thing, actually, the last topic I'll talk about regarding Recovery Services Vault is that when you do a restore from a Recovery Services Vault database backup, you've got 3 possible destinations for that restore. So I can restore to an alternate location. I can restore to a different VM that is in the same subscription. I can overwrite the existing database. So if I'm doing a point-in-time restore because somebody ran that delete statement without a where predicate this morning, I can do the point-in-time restore over the existing database. Or I can generate a file. I can restore to file, and this will actually create a .bak file at a location that I specify. Very important point is that destination, any of these destinations need to be in the same Azure subscription as the source VM. And this can be a challenge when you have a prod subscription and a test subscription. So say I've got a prod database and then I've got a test environment where my devs are doing all the changes, and I want to refresh that test database every week. You can't restore to file to that test subscription because it is in a different subscription than prod. So what you need to do is back up that database to a file in the prod subscription and then copy that backup file to the destination subscription, in this case test, and from there you are going to do the restore to your test instance. So just know that it can be done, but it is a 3-step process where if it was possible to restore to the other subscription, it would effectively be a 1-step process. You'd be able to restore directly to that instance. But that is how this works. And that takes us to our Recovery Services Vault demo. Let me jump back over here. So here I am looking at my Recovery Services Vault, and you've got a couple of options here on the right. Backup under Getting Started is where you will go when you are setting up the backups for your VM, and then once the backups are set up for your VM, you have the ability to set the backups for the SQL Server databases running on that VM or those VMs. I have already done this. I've configured the backups for my VM and for the SQL databases running on that VM. And to see what that looks like, I come here to Protected Items and I click on Backup Items. And this will show me that I have 4 SQL in Azure VM backup items and then 1 Azure virtual machine. And you can back up other things using RSV. I mentioned VMs and virtual machines. You can also back up SAP HANA and Azure storage. You can back up Azure files using this. So if you need to do those things, this once again gives you that single pane of glass. So because we're interested in SQL Server, I'm going to click on Backup Items in SQL Server. And these are my 4 databases that are being backed up. And I have chosen to back up my system databases. So I've got MSDB master and model in addition to wide world importers. It gives me the instance name or the AG that's being backed up. And then it tells me the type. So that's going to be either standalone instance, which is what this is, or it will show me always on availability group. And then there's my backup status. So all 4 of these databases are showing a healthy backup status. If I click the ellipses over here on the right, I have a couple of options. I can back up now, so I can fire a full backup for any of these databases at this point in time. I can select restore, or I can stop the backup, and talked about the idea of enabling or disabling the backup within, for whatever purpose. You can do it from here. And then finally, I've got to delete backup data, and that's not activated because I have to stop the backup before I'll have the option to delete backup data, and something I can mention a little bit more when we get into it. So if I click restore, and actually let me select wide world importers for this. Why is that not? Okay, so it takes a second to become active. If I click restore here, this is where I will see my options. So you can see I've got alternate location, so I can specify a server. I can overwrite my DB. And I can select, apologies for moving around. I can select a restore point. So if I click select, I can select a log point in time, or I can restore from a full or any of the differentials I have access to. And I can set thresholds for what files I want to see. So for example, if I am retaining more than 7 days worth of backups, I could specify, a date range. And then finally, I can restore as files. And this is where I would specify a server, and I would give it a destination path on the server. And that would write that backup file, that .bak file, to the location I specify. And once again, I can select a restore point here, and it works the same way. You'll notice it gives me a graphical representation of what's available. It doesn't show it here, but sorry, I missed the logs button. So looking at a select restore point, if I wanted to do that point in time restore from the logs, it's going to show me the available logs here. So I can either specify a time by typing it in the dialog box here, or I can click on this and it will change it. You can see that it's flipped to 2:13 p.m. And the reason that this entire bar isn't populated is because this VM was shut down. So I turned it on shortly before starting the recording. So that is my point in time recovery. If this had been on the entire time, this entire bar would be green, and then I'd be able to mouse over and select restore points within that green. So those are your options for restoring from the Recovery Services Vault. A couple of other things to point out regarding Recovery Services Vault is if I come into backup. So if you were going to be enabling this the first time, this is where you would select that your workload's running in Azure. You can back up a virtual machine as SQL Server and Azure VM, or the other two options, the Alright, it's clocking while it makes the switch to SQL Server and Azure VM. But you can also choose SAP HANA or Azure Storage there. And not sure why that's clocking as long as it is. Here we go. Alright, so give this a second. What I want to show you is there is an option to auto discover. So basically the process of configuring this is you register the VM to be backed up through Recovery Services Vault. Once that is done, you can discover the databases on that virtual machine. And this is running the discovery. And so it will show you all of the databases that are running on instances of SQL Server on that VM. And then from there, that is where you configure the backups for those databases. Jump back over here to configure backup because I've already discovered the backups. And this is what I want to show you. Actually, let me jump back and do that again. So I'm configuring backups. This is where I choose my backup policy. So I've got a backup default backup schedule, and it has the backup frequency, and then it's got information about retention of weekly, monthly, and yearly backups. So this should be familiar from having looked at point-in-time restore and long-term retention for PAS. It's a similar thing with Recovery Services Vault. I then can specify diff backups. So in this case, I'm running my weekly on Sunday. I'm running my diffs every other weekday. I set a retention policy for my differential, and then how frequently my log backups run and how long they are retained. Then I can click Add here to add additional databases. And right now, there is only one database available to me to add because the other 4 databases, Master, Model, MSDB, and Wide World Importers, have already been added. So I can select that checkbox, and then this is the dialog I wanted to show you. So this auto protect is currently off. If I turn this on, what that will do is when an additional database is added to this instance, to the FBG SQL VM2/MS SQL Server instance, it will automatically get pulled into the backup policy. So I'm going to enable that here, and I'm also going to set backups for the _copy database. If I click OK, you can see that it is specifying the database, and I click Enable Backup, and this will start the deployment, and it will give me this configure protection, and it will run for some time, and the deployment is now succeeded. If I go to my resource and take a look at backup items, it may take that deployment succeeded. So let's see. Look at my backup items. It's fetching data from the service. All right, so it just shows 4. It may take a second to populate. So what I will do is, I'm just trying to think if there's anything else I need to show you from here. I'm going to refresh that. I guess one other thing I can show you while we're waiting, I already did show you restore, so that's good. You know about point in time. This is where you would stop the backup, so you can stop it here, or if I click through to any one of the individual databases, I will also have a stop backup option on the database pane. I mentioned delete backup data, so there's a setting within Recovery Services Vault called soft delete, and that is the default. And so if I was to stop this backup, I can remove the database. Oh, I clicked a link I didn't want to. I could remove the database from the backup policy. With soft deletes turned on, 2 weeks worth of backup data will be retained. So from the point in time that I remove it from the policy, those backups will be retained until 14 days go by and they're all deleted out. You can disable soft delete, and then you can delete backup data, and that will basically fully remove the database from the policy and from the recovery services vault. So in the case that I talked about where they had GeoRedundant policy configured for test and they wanted to switch it to local, they needed to remove all the databases, delete the backup data, and then make the switch over. So let's just see if it has added, and it still has not shown up. But I think once that processes through, we will see that underscore copy here. I won't keep you watching your screen while I wait for that. So what I'll do is flip over to my slides and then just go through my resources. So this is a series of links that kind of apply to what I've talked about. More information about automated backups for SQL database and managed instance. And it talks about the redundancy and your ability to flip from local to GeoRedundant. Link to Ola Solution's maintenance solution. And this is actually, this is linking to olaholmgren.com. And so there'll be a link there for the maintenance solution, and there'll also be links to download just the backup specific portions. Backup and restore options for SQL Server on Azure VMs, and then Azure Recovery Services Vault. So that's the what we just went through, and this will give you a tutorial to run through all of that. And then I will add an additional couple of links, one for the cost estimator. There was one other resource that I was going to add, but that will get added in before I send the deck over. With that, I just want to thank Microsoft for supporting the people who put on the Data Platform Summit. Without them, we wouldn't be able to do this, and I very much appreciate the opportunity. And then finally, there are a couple of ways to win prizes. You can post a selfie to Twitter with hashtag DPS 2021. You can give your session and conference feedback, and you can visit sponsors and exhibitors. And there are the Twitter handles for the Data Geeks and the Data AI Summit. So with that, I thank you for attending, and let me just do one last check. All right, still nothing, but trust me that the underscore copy database will show up as being backed up. So thank you very much for attending, and enjoy the rest of your day and the rest of your summit.